I will explain about the main components of overhead transmission lines in today's classes. Now, what are the main components of overhead lines? An overhead lines may be used to transmit or distribute electrical power. The successful operation of an overhead lines depends to a greater extent upon the mechanical design of the line. While constructing an overhead lines, it should be ensured that the mechanical strength of the line is such so as to provide against the most probably weather conditions. In general, the main components of overhead lines are: first one is the conductor, next line support, insulator, cross arm, etc. First one is the conductors. The conductor is one of the vital item, as most of the capital is invested for it. Therefore, the proper choice of material and size of the conductor is to considerable factors. The conductor's material used for transmission and distribution of electrical power should have the following properties. So some properties are there for proper conducting material selection, like number one, high electrical conductivity, because we know that the function of conductor is to carry the whole current which is passing through the transmission and distribution line. So high conductivity must be required for a conducting material. Next one is the high tensile strength in order to withstand the mechanical stress. Because generally the transmission lines are used in the outdoor area, so high tensile strength or mechanical strength are required for this wire. Next, low cost, so that it can be used for long distance. We already know that the transmission line is the longest path of the power system, so huge initial investment costs are there. If the cost of the transmission conductor wire is comparatively low, then that is beneficial for the investor. Next point, low specific gravity, so that the weight per unit volume is very small. All above requirements are not found in a single material. That is the problem. Therefore, while selecting a conductor material for a particular case, a compromise is made between the cost and the required electrical and mechanical properties. That is a big problem, because not a single material is present where all the properties are found. So we can select or compromise some factors from it for a particular material. Like for example, in case of copper, the conductivity of the copper is very high, the tensile strength of copper is very good, but main disadvantage of copper is that the cost of the copper is very high. So copper is not used generally for the transmission wire. Next case of aluminium. If we consider the aluminium, the cost of the aluminium is very low compared to the copper. The weight of the aluminium is comparatively lighter, but the tensile strength of aluminium is very poor. So that is a problem. So to solve these two problems, generally we can use the aluminium conductor steel reinforced, which is denoted by ACSR, as a transmission wire nowadays. Now, the commonly used conductor materials are: first one is the copper. Copper is an ideal material for overhead lines owing on its high electrical conductivity and greater tensile strength. It is always used in hard drawn from as standard conductors. Although hard drawn electrical conductor, the conductivity is very high. Copper has high current density, that is, the current carrying capacity of copper per unit of cross section area is quite larger. This tends to two advantages. Firstly, the cross section area of the conductor is smaller, and secondly, the area offered by the conductor to wind load is reduced. Moreover, this metal is quite homogeneous and durable, has high sharp value. There is hardly no doubt that the copper is ideal material for transmission wire, but the main disadvantage of copper is that the cost of the copper is very high. So nowadays that tends to use the aluminium in place of copper. Now the aluminium. Aluminium is cheap and light as compared to the copper, but it has much smaller conductivity and tensile strength. The relative comparison of two materials are that first point, the conductivity of the aluminium is 60% that of the copper. The smaller conductivity of aluminium means that for any particular transmission efficiency, the cross-section area of the conductor must be larger in aluminium than in copper. For the same resistance, the diameter of the aluminium conductor is about 1.26 times of the diameter of the copper conductor. The increased cross-section of aluminium exposes a greater surface of wind pressure, and therefore supporting tower must be designed for greater tensile strength. This often required the use of higher tower with consequent of the greater sag. Next point, the specific gravity of aluminium is 2.71 gram per cc, that is lower than the copper, because the specific gravity of copper is 8.9 gram per cc. Therefore, an aluminium conductor has almost one half of the weight of equivalent copper conductor. For this reason, the supporting structure for aluminium need not be made so strong as that of the copper conductor. Next point, aluminium conductor being light compared to the copper. Next point, due to the lower tensile strength and higher coefficient of linear expansion of the aluminium, the sag is greater in aluminium conductor than compared to the copper. Now, considering this combined property of the cost, conductivity and tensile strength, weight, etc., aluminium has an edge over copper. Therefore, it is being widely used as conducting material. It is particularly profitable to use aluminium for heavy current transmission, whereas the conductor size is larger and it costs from the major proportion to the total cost of the complete installation. Now, the steel cored aluminium. Due to low tensile strength of the aluminium conductor produce greater sag. This is the main problem of the aluminium wire. So, steel cored aluminium conductor is designed. It is also known as the aluminium conductor steel reinforced. In order to increase the tensile strength, the aluminium conductor is reinforced with a core of galvanized steel wire. The composite conductor thus obtained is known as steel cored aluminium and abbreviated as aluminium ACSR, that means aluminium conductor steel reinforced. Here, a few number of aluminium conductors are placed in the outside of the structure, whereas in case of the center area, the galvanized steel conductor is placed. Here, steel conductor is provide the tensile strength of this particular wire, and we know in case of AC system, the skin effect is a vital factor. In skin effect, we know the maximum current passing through the outer surface of the conductor area. So here in this ACSR conductor, the outer side is designed with aluminium, and we know the conductivity of the aluminium is greater than the steel. So aluminium uses current carrying conductor and steel give the tensile strength of the system. There are some advantages of this system. First point, the reinforcement of steel increases the tensile strength, but at the same time keeps the composite conductor lighter. Therefore, steel cored aluminium conductor will produce smaller sag and hence longer span can be used. Next advantage, due to smaller sag, the steel cored aluminium conductor tower of small heights can be used. Next one is the galvanized steel. Steel has a very high tensile strength. Therefore, galvanized steel conductor can be used for extremely long span for short line selection composed to abnormally high steel due to the climate condition. They have been found very suitable in rural area where cheapness is the main consideration. Due to poor conductivity and high resistance of steel, such conductors are not suitable for transmission large power over the long distance. However, they can be used to advantage for transmission a small power over a small distance where the size of the copper conductor is a vital factors. Now, last one is the cadmium copper. The conductor material now being employed in certain case in copper alloy with cadmium. An addition of 1% or 2% cadmium to copper increase the tensile strength about 50% and the conductivity is only reduced by 15% below than the pure copper. Therefore, cadmium copper conductor can be useful for long span. However, due to high cost of the cadmium, such conductors will not economical for the line of small cross section. That is, when the cost of the conductor materials is comparatively small compared to the cost of the supports. Next material is the line support. The supporting structure for overhead line conductors are various types of poles, towers called the line support. In general, the line support should have the following properties. Some properties are there, like number one, high mechanical stress to withstand the height of the conductor and wind load, etc. Next point, light in weight without the loss of mechanical strength. No compromise is there for mechanical strength of line support. Next, cheap in cost and economical to maintain. Next, long life. And last advantage, easy accessible of conductor for maintenance. These are the properties for the line support. The line support used for transmission and distribution of electrical powers are various types like wooden pole, steel pole, RCC pole, etc. The choice of supporting structures or particular case depends upon the line span, cross-section area, line voltage, cost and local conditions. First one is the wooden pole. These are made of the wood. These are basically made with the help of wood and say up to 50 meter and where the length of the wire is sub 50 meters. Such there are some disadvantages of wooden pole because wood is not suitable for the transmission material. Second one is the steel pole. The steel poles are sometimes used as suitable for wooden pole. They process the greater mechanical strength, longer life and permit longer span to be used compared to the wooden pole. Such poles are generally used for distribution purpose in the cities. This type of support need to be galvanized or painted in order to provide the long lifespan. The steel poles are therefore the rail pole, the tubular pole, the roll steel joint, etc. So there are different shapes. Next one is the RCC. RCC means reinforced cement concrete. The reinforced concrete pole have become very popular as the line support is last few years. They have greater mechanical strength, long life and permit longer span than steel poles. Moreover, they give good outlook, require little maintenance and have good and have good insulation properties theirs. So these are the poles, and last one is the steel towers. For high voltage lines, the towers are generally used because towers are not only the line support, it is robust, so it can withstand high mechanical stress and weight, etc. And another types of line support is called the cross arm. Cross arm is basically connected with the pole. Over the cross arm, some different types of insulators are used, and these insulators are directly attached with the transmission wires.